Okay, so today what we're going to be talking about is properties of parabolas. So yesterday we talked about our basic things that went along with quadratics, right? So we talked about something called standard form. What was standard form? Good job, guys. Okay, good. Ax squared plus bx plus c. That's our standard form, right? Okay, we also talked about something called axis of symmetry. What was the equation for axis of symmetry? Great, that's the axis of symmetry. We also talked about vertex, right? What do we know about the vertex and the axis of symmetry? How do they relate to one another? Good. The x of the vertex, let's call it AB, is my axis of symmetry. So x equals A would be my axis of symmetry if my vertex was AB. Make sense? Huh? First letter, yep. Yep, your x value. Okay, we also talked about the domain of any quadratic. Give me more than x's. Yes, domain means my x values, but what is my domain of any quadratic function? Somebody said it. All real numbers, okay? So from negative infinity to positive infinity is going to be my domain. We also talked about range. How did my vertex help me to figure out what the range was? We already used the x value, right? Yeah, something to do with the y value. So first we needed to decide, was this a positive ax squared or a negative bx squared? Because if it's positive, we know that the quadratic is going to be upward with a minimum. If it's a negative ax squared, we knew it was going to be downward with a maximum, right? So let's say it was a positive ax squared. That means my parabola is going to look something like this. Okay? My vertex is the point negative 2, 3, which means my range is going to go from 3 to infinity. Okay? So that y value of the vertex helps us to determine what my range is, what y values are being used. Okay? We also talked about different types of notation. So let's see if we remember this. Let's say I have negative infinity to 7. What type of notation? Interval notation. Good. Okay, let's say I had negative 2x infinity. Set builder. Good. Okay, that was great review from yesterday. Nice job, guys. Ready to move on? Okay, so yesterday we spent a lot of time with that standard form. We're going to move on from standard form and we're going to talk about something called vertex form. Okay, so vertex form is just another way to write these quadratics, but vertex form makes it really easy for us to pull out what the vertex is, as well as the axis of symmetry. Okay, so that's what we're going to look at today. All right, so vertex form, and you have to have this memorized, is y equals a times x minus h quantity squared plus k, where hk is your vertex. Okay, so do you see the h, you see the k? See where they are in position in this equation? Okay, so we can really quick and easy pull out these vertexes when we're in vertex form. It also makes it pretty easy to graph. Okay, so you need to know that that a value that sits out front, what that's going to do for us is going to allow us to stretch and shrink, make wider or narrower that parabola. Okay, so that's what that a value does. All right, so how do we go from standard form into vertex form? That's what we want to look at today. Okay, we're going to use a process called completing the square. You're going to be completing the square all year long, so this has to be, you have to be able to do it really well and rather quickly. Okay, so we're going to do it a couple times. It gets easier as you do it. Are you ready to give it a shot? Okay. Okay, so in order to complete the square, our goal is to get a perfect square in my trinomial. Okay, we don't have, well, I guess we kind of do. With this one, we have a perfect square for C. Do we not? Tell me how this factors. Speak up. X minus 2, x minus 2, right? Pretty easily factored. So this can be written like this. Do you agree? All right, so if I'm looking at vertex form, y equals x minus h quantity squared plus k, do you notice some similarities here? Yeah, you could see this piece here, right? That's there. So what's the number that sits out front of this? It's 1. Yeah, A, which is 1 in this case. How about back here? 0. Okay, so now is it the exact same form as this? Absolutely. Okay, so this would be considered vertex form. Okay, so to figure out what the vertex form is, remember, vertex is HK, right? The vertex over here is at x minus h, so we've got x minus 2, so h is what? It's 2, positive 2. Okay, and k is 0. Yes. How did I get h? Okay, it's minus 2, right? Minus h. What is h specifically? 2. Okay, so the vertex is 2, 0. What do you think? That's not bad, right? So now, is it always going to be that this c term's a perfect square for us? No. So sometimes we have to figure out how to change that c value so it is a perfect square. So that's what we're going to look at next. Okay? All right, someone want to tell me on the next page what's the first example? Oh, yeah, I guess we are. Okay, so sorry about that. I forgot. So here's my function, right? I want to prove to you that this is the same thing as what we just determined. So I've got x squared minus 4x plus 4. So go ahead and graph that, please. X squared minus 4x plus 4. So here's that graph, right? What's the vertex, by the way? 2, 0. So was the vertex in vertex form the same as the vertex in standard form? Yeah. Okay, so what was my function in vertex form? Good. X, that's not a parenthesis, is it? Nope. X minus 2, quantity squared. Should it be the same thing? Should the vertex be the same? Thank you. Nice catch. Same exact thing, right? Okay. So is vertex form changing it in any way, shape, or form? No. Nice catch. Okay. So let's try some more algebraically. Okay. X squared plus 6x plus 8. All right, so the first thing I need to do is I need to look at my c term. Is my c term a perfect square? No, it's not. Okay, so we need to fix it. Okay? So here's what we're going to do. We're going to come up with a new c term. Okay? It's actually really simple to do. There's a quick formula that lets us do it. All right, so I'm going to rewrite this, and I'm going to leave like a space, and then I'm going to put the plus 8. Okay? Now, can we randomly add a number to something just for the heck of it? No. So what I have to wind up doing is I'm going to add a number in there, but I'm also going to subtract it out. So if I add the same thing and subtract the same thing, they kind of cancel each other out. So it doesn't change the value or the actual equation itself. It's just going to make it look a little bit different. Okay? So the way we find this new c term, are you ready? You're going to do b over 2 squared. Okay? What's b? 6. Good. Does everybody know how we got b? Okay. So what's 6 divided by 2? Squared? 9. All right, so there's my new c term. So here's what you're going to do with that. Are you ready? I'm going to add 9. And on the end, I'm going to subtract 9. Because if I add 9 and subtract 9, am I really doing anything? Okay. So what we're going to do now is you see this piece right here? That's what we're going to play with. That's the piece we're going to factor. Okay? So how does x squared plus 6x plus 9 factor? X plus 3, x plus 3. So I can write it as x plus 3 squared. And then I have that plus 8 minus 9, which gives me, is that in vertex form? Good. What's the vertex? Careful. -3, -1. Remember, it's x minus h quantity squared plus k. So if it's now a plus, that means I had minus a negative, right? So the vertex is -3, -1. What's the axis of symmetry? Good. What's the range? -1 to infinity. How do you know it's going up and not down? It's a positive x squared. Is this going to be closed or open? And this is going to be? Good. You getting the hang of this? Excellent. All right, so are they always going to be with a leading coefficient of 1? No, probably not, right? So we have to know one more method with this, okay? So what do you think? Is this hard? No, you just have to remember the steps that go along with it. Okay, so somebody tell me what the next one is, please. Y equals? Great. Okay, so I don't like that -3. It's bothersome. And it's not a GCF, is it? It's not. But I can pull it out. How? That's a good question. No? So here's what we're going to do. We're going to take it, and we're going to take it out front. You can take it out. It's just not going to be pretty, okay? Which, whatever, not everything is pretty. Apparently, my hair today. Okay, so we're going to take that -3 out front. Okay, the way we get what goes in the parentheses? Yeah, divide it out. Okay, so we get x squared plus 4x plus 8/3. Don't stress about the fractions. It's not that big of a deal. Just like what? Aw. I didn't hear. It's not nice. Okay. So, is 8/3 a perfect square? I want it to be, though, right? So that means I have to find a new C term. Okay? I got 2 blanks to fill in, right? How do I find my new C term? Great. What's B?
4.
So it's 4, right? What am I going to do? Add 4, subtract 4. Okay? Now, if you get it's always adding in this spot. It's always adding. It's always subtracting here. Okay? It's always adding, subtracting. Otherwise, it doesn't factor. Okay. That's how you find your new C term. Okay. So now you're going to take and you're going to factor this piece. How do we do it? X plus 2 quantity squared. Great. Is it -4/3? Great. Perfect. Then that's what it is. Okay. And that's it. Are we in vertex form? All right. What's my vertex? Great. Is it pretty? No. Are they all going to be pretty? No. Right here.
So is it any time it's positive, you change it to negative?
Yes.
Negative.
Exactly. Okay. All right. So I want you to try the next one. You're going to do it the same way. Okay. You're going to try the next one. What is the next one so I can write it down? Y equals. Okay. So go ahead. I want you to do the same exact process again and put it into vertex form for me. Okay. All right. First step, guys. Divide everything by 2. So I'm going to take that 2 out. We're going to have x squared plus 6x plus 19/2. Are we okay with that?
Yes.
All right. Jeez. Okay. Now what? Right. Got to find that new C term, right? Okay. So you have 6 over 2 quantity squared, which is going to give us 9, which I'm going to do what?
Plus 9.
And? Great. Okay. Great. Plus 1/2. Are we okay with that? Vertex? -3 1/2. How many people got this right? Nice job. Okay, good. No, that's as hard as it gets. Okay. All right, so we're going to talk a little bit about translations of quadratics. What is a translation? To move something. So what can a movement be? Up, down, left, right. How else? Reflecting, shifting, and stretching. Okay? To stretch something or shrink something. So you have to know what the values kind of do for our function. Now, do you guys know what a parent function is? Have you heard that before? Okay. A parent function is a function that basically hasn't been messed with. I haven't added anything to it. I haven't subtracted anything. I haven't multiplied anything. I've done nothing to it. It's as basic as it comes. X squared is my parent function for quadratics. For linear, my parent function is y equals x. Make sense? For a cubic, my parent function is y equals x cubed. Have I done anything to them? No, they're the parent function. Okay? From our parent functions, we get everything else. We can transform our parent functions to get other functions, okay? So what I want you to do on the next page is I want you to graph the parent function y equals x squared. And we're going to play a little bit, okay? So there's my parent function. What's the vertex? 0, 0. Good. My vertex is 0, 0. What is my axis of symmetry? X equals 0, okay? Remember, it's vertical, so my axis of symmetry is x equals 0. So here's what we're going to do. We're going to take this parent function, we're going to move it around. You guys know how to grab things, right? Okay. So right near the vertex, I want you to grab that vertex, and this is going to allow you to take this function and move it left and right. And as you do that, I want you to pay attention to what happens to your equation. Now, obviously, I bumped off my axes. Oh. Control Z. Okay. All right, so if I'm moving left to right, what's changing in my expression or in my equation? Is the decimal at the end changing? This is kind of not a nice view of it. Let's do this. I'm going to go in and double click this. All right, so let's say I add 2 on the end of the function. What do you think will happen? What do you think? Let's find out. Where'd it go? Up 2. Okay, so if I'm adding to the end of my quadratic, what does it do? Up. What if I subtract? Okay. So that moves it up and down. How do you think I move it left and right? Adding directly to the x. Okay. So in here, right? So let's say I do plus 2. Where do you think that's going to go? To the left. Okay, so if I add on the end, it goes up. If I subtract on the end, it goes down. If I add on the inside, it goes left. And if I subtract on the inside, it goes. Do you guys remember these things? This was 9th grade, right? Okay, so that covers those pieces. But there's a variable that we haven't really talked about, right? What variable have we not talked about? We've got y equals ax minus h squared plus k. We talked about h. We talked about k. What haven't we talked about? A. What do you think a does? Ah, okay. So I'm going to change this back to my parent function. There's my parent function, right? I'm going to grab up here, and I'm going to take and move this. Okay, so do you see what's happening to that value of a? All right, so when a gets smaller, what's happening to my quadratic? It's wider. A gets bigger? It's getting narrower, right? How about when it's negative? It's upside down, right? So this has a what? Maximum. This has a. Okay. So do we understand that value of a? So the bigger a is, the narrower. The smaller a is, the wider. Are we all right with that? That's all I need you to know for that. Okay. Really what you're going to be doing with these, if you get a question like this on an exam, you're going to be graphing it, you're going to be pulling up the table, and you're going to be plotting points, which you are all 100% capable of doing. Agreed? Okay. Let's go to the next page, please. Hopefully everybody picked up a ruler and a piece of graph paper, which wasn't back there. That's awesome. I'll give you your graph paper. Hold on. So what form is this, guys? Yeah, it's vertex form. Tell me what the vertex form is, please. 2, 3 is my vertex. What's my axis of symmetry?
X equals 2.
Am I going to have a maximum or a minimum?
No, X.
Maximum. Why? It's a negative, right? What's my range? Three to negative infinity. But when I write this, negative infinity to 3. Okay, good. So we've got some good information here, right? Just from looking at that one equation. So how I'm going to start is by graphing that axis, or the vertex, which is my hair in the way? Okay, apologize. 2, 3. Okay, so there's my vertex. 2, 3. Okay, I know that that's going to be the maximum, right? I also know that through this point passes the axis of symmetry. The nice thing about the axis of symmetry is it makes our work less. It's half the work we need. If we know that everything's going to be symmetric about that line, I only need to do half the work. Okay, so when I go to find points, I only need to do a couple on the right-hand side or the left-hand side of that axis of symmetry, because on the left-hand side, it's going to match up to the right-hand side. Make sense? Okay, so if this is 2, 3, let's say we find 4, 6, 8. Anybody know why I chose even numbers? Why is it easy to work with? Look at the equation.
Because it's a half. And that's 2.
Yeah, you're multiplying by half here, right? So if I'm subtracting by 2, if that number that I have here is even, multiplying by half is going to be really simple. Okay? So if I start with the value of 4, are we ready? We're going to move fast for time. Negative 1/2, 4 minus 2 squared plus 3, right? 4 minus 2, 2 squared, times negative 1/2. Negative 2 plus 3, 1. So I have the point 4, 1. So I'm going to come back here. I've got 2, 3, 4, 1, which means I also have, it's got to be symmetric to the axis of symmetry. 0, 1. Very good. Great. Okay, we're on the right track. Let's go to 6. Negative 1/2. 6 minus 2 squared plus 3. 6 minus 2 is 4 squared. 16 times the negative 1/2. Negative 8. There you go. You getting the hang of that? We know multiplying by half, same thing as dividing by 2. Okay? So I've got the point 6, negative 5. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So what other point do I have? Negative 2, negative 5. Very good. Do I need any more? No, this is good. Okay, so when you're sketching this in, make sure you extend all the way to the edge of the graph. I saw some of your Regents exams last year. You do not extend. You need to extend, please and thank you. And make sure that you label y equals negative 1/2, x minus 2 quantity squared plus 3. Ta-da! How'd we do? Great. Okay, we're going to finish this lesson tomorrow. Okay. Remember, you do have a weekly project due Friday, weekly project 6. Your homework is to continue on with pages 1 through 4, so you should be able to do pretty much everything that's there now. Okay? Nice job today, guys. That was perfect timing.